This video covers integrating a product by a method called integration by parts, and it swaps a difficult product integral for a much easier one. Now, there is a formula that's in the formula book, and this is it, but in practice everybody remembers this by the grid that you're going to see in a minute. Now, I'll just write out this formula and talk you through it. So, this is for integrating a product in this form where you've got one function u and another function we've expressed as a derivative, dv dx. To integrate that product, we're allowed to swap things around so that we end up with u times v, which will be the integral of this part here, minus the integral of du dx v dx. So it swaps things around. Relatively difficult to see what's going on here, but let's watch this in action with an actual example. Now we're going to integrate x sine x dx. And what I mean by grid is that we always draw out something like this. And I'm going to put a u there, and a u prime there, and a v there, and a v prime there. So u and the derivative of u, v and the derivative of v. Now, one of the critical parts of integration by parts is choosing which of these two functions is going to be your u and which is going to be your dv dx. I'm going to choose x as my u, and I'm going to choose sine x as my dv dx, or v prime. The reason I did this is that to complete this grid, when I move from x to derivative of x, that's just going to differentiate to 1, which is nice and easy. It's going to help a lot later. Now, I need to move from dv dx here back to v, so I need to integrate sine x, which integrates to minus cos x. Now that I've made my grid, I always just remember this using almost like muscle memory, but you can use the formula as well, and the formula is in the formula book during the exam. So my integral here is going to be changed to uv, that's the uv there, so x times minus cos x, which I'm going to write as minus x cos x, minus the integral of that diagonal. So I always remember it, that's the left hand side minus the leading diagonal there. Now I'm going to put both these minus signs in here, and I think it's quite important that you do that to make sure you can debug the problem later. Check for any silly mistakes. We all know that that's going to turn into a plus, but let's do that in a minute. So I'm going to rewrite that now as x cos x. I'm going to resolve that double negative there into a plus integral of cos x dx. And at this point we can see that we've turned this relatively difficult integral here, x sine x dx, into something that's solved already, plus now an easier integral down here, which we can now work out. So I've got minus x cos x plus integral of cos x is simply sine x. Now we mustn't forget the arbitrary constant on the end. And at that point, that is my integral.